last speaker of Fat Splat is Robin Burke. So let's actually start out by giving him some applause to the last speaker.
Okay, great. All right, I do appreciate everybody who stuck around till the sweet end, not the bitter end, the sweet end here of what has been really a terrific conference. I've learned a lot, and so I hope maybe people will learn a little from what I'm talking about. So this paper is on balanced neighborhoods for multi-sided fairness and recommendation. This is joint work with myself and a couple of my students who are here in the audience today, so I'm grateful to them. And I'm also grateful to Michael Ekstrand for giving this great survey of recommender systems and recommender systems research. And I kind of knew he would do that, so I have very little sort of overview of recommender systems because I know he's explained that really well. Okay, I'm going to grab this so I can see my slides. All right, so, and one thing I think is interesting about recommender systems as opposed to a lot of the classification work that's been discussed over the last 2 days is, we are kind of on the other side of Aristotle's dictum, right? So he says equals should be treated equally, but in recommender systems, we're dealing with unequals who should be treated unequally, and the real question is how? And in what ways is it appropriate to treat them unequally? I want to say a little bit about what's different in this work from the work that you've heard already. So one is that it's a technique that can be used for both consumer side and provider side fairness. That distinction's already been brought up. I'll talk a little bit more about it. Another thing which I think is an interesting consequence of this work, we're not actually optimizing fairness directly. We're actually discovering that a different kind of optimization can end up in fairer recommendations. And then the third thing, which is a little bit different from what Michael was talking about, is we're actually looking at what gets recommended as opposed to sort of error rates or differential performance for different groups. The idea of the filter bubble has already been brought up, and I think that there's this kind of more general concept that's out there of over-personalization. If we have systems that are personalizing themselves to user behavior, there's this danger that users could be trapped in, receiving content that only has a limited scope. And the real danger of that is it is an open feedback loop, like the one we saw for predictive policing, in that if you only show me stuff that is, that has been transmitted based on this filter, like in the case of, Parisser's example, if you only show me liberal friends, I'm never going to hear the opinions of the others. And so I'm going to be, sort of pushed farther and farther into a particular niche. Okay. And this is a danger, just in some sense, in the recommender systems evaluation paradigm itself, something that I think Michael also laid out particularly well. We're always, for the most part, I don't own a search engine company, and so I'm forced to do evaluation pretty much based on historical data that I can get. And so we're always in this situation of recommending stuff that we already knew that the user liked, and you get what you optimize for, so this is kind of inevitable in a way. Now, there is also an undercurrent that says, well, let's just get rid of this, okay? Do we really need recommendation after all? It's an evil outgrowth of the surveillance economy, why do we have this, okay? And I would like to push back a little bit, and I can hardly claim to be unbiased. I've been working in recommender systems for 20 years, so, so take that, as you might. But consider this, like, I'm searching for a plumber. I live in an old house in Evanston, Illinois. I do not want recommendations of plumbers in Evanston, Wyoming. It's a perfectly nice town, I'm sure. But those plumbers are not going to get on the highway for 12 hours to come fix my pipes. It's even worse the other direction, right? So if you're in Evanston, Wyoming, and there's way more plumbers in Evanston, Illinois than there are in Evanston, Wyoming, you really don't want those most popular recommendations from that city far away in Illinois that isn't going to help you at all. So I think we need to keep recommendation. Again, people may differ about that. But if we're going to do that, if we're going to keep recommendation, we need to find a way to combat this problem of over-personalization. So it's a balancing act. We're trying to achieve a certain kind of balance here. We want to represent other kinds of considerations in recommendation beyond just, is this the thing most like the user profile that we've seen in the past? Not just the end user, so that's kind of what the profile we have, but there could be other stakeholders. And this is something that I thought was really great in the tutorial yesterday on fairness measures, is this idea that, whether something is fair or not, how we measure fairness, depends to a certain extent on what the stakeholders are whose opinion we're considering. And I think this is also important in recommendation. So we may need to think about the goals of other stakeholders, what they want out of the system. And this idea of multi-stakeholder recommendation is a very new idea in recommender systems. It's something that I've been working on for the past couple of years. And an outgrowth of that idea is, well, there might be this need for fairness. So one of the stakeholders might care about fairness. Now, if I'm the consumer, I want good recommendations for me. I might not care about the others, right? So if I'm getting good job recommendations for me, I might not care if there's some other party that's getting worse job recommendations. But the company that's delivering those recommendations very much might care about how they're distributed among the whole user base, what the experience is over time. And so then that stakeholder, the business itself as a stakeholder, should be able to exert its interests in the recommendation process. Okay, so, and there are different ways that might shake out. And so this is kind of what was already alluded to in terms of different kinds of fairness. So we might have consumer fairness, where what we care about is making sure that, that users all get fairly treated by the system. Different quality of service was talked about by Michael. I'm talking about, later on in this talk, I'll talk about looking at how different classes of users might get different recommendations and whether that might be bad. And then there's also this question about provider fairness. Are items from different providers being treated fairly? And this also has some interesting implications. For example, in long tail recommendation, often in these kinds of recommendation environments, you have items that are recommended rarely as opposed to sort of top hits or #1 bestsellers. And a system that only is recommending the popular stuff is going to reinforce, again, those preferences, and long tail items will be left behind. And then that's a system that's not very dynamic. The specific example I want to talk about from our paper is Kiva.org. I don't know how many people are familiar with Kiva.org, but it is a crowdsourced micro-lending site. And so they collect loans from individuals in developing countries. These are usually entrepreneurs looking for small amounts of capital to grow their businesses. A typical borrower on Kiva.org might be, I think I saw one of these the other day. So it was a woman who has 3 goats and she wants to buy a 4th goat and it costs $300. And if she gets that 3rd goat, she'll be able to raise some little goats and sell them, and eventually she'll be able to pay back your $300. So Kiva, as an organization, they have a goal, part of their mission, to have equitable access to capital across different regions of the world, across different economic sectors, and between men and women as borrowers. So that doesn't come from me, that's their mission. And so that's, we've been working with them to try and help them achieve that mission. They don't actually have personalized recommendation on their site right now, but this is something that they're very interested in. So we still want to have personalization. If you're interested in supporting aquaculture, you should be able to support aquaculture. We're not going to tell you what you should be supporting. But we also want to factor into that the goals that the system has for achieving, in this case, the equitable distribution of capital through this system. And as in a lot of the other work that's been discussed here at this conference, there is a tension between trying to achieve good recommendation and trying to achieve these fairness goals that you might have. Part of it is because we have this existing bias in the data. So if biases comes in with the data, bias is going to come out in terms of recommendation, and that could cause disparate impact. So for example, we were able to identify in the Kiva data regions of the world where loans were less likely to be funded and regions of the world where loans were more likely to be funded. And again, this is a self-reinforcing problem because if I only recommend loans from those most popular regions, the other ones won't get funded even more, and those biases will continue. So how do we preserve recommendation, but also or personalization, but also try and reduce this impact? And another goal of our work here was to have an idea that is general enough that it could be applied to both consumer and producer fairness. Okay, so let me just say a little bit, very little because I'm running out of time, about collaborative recommendation. I'm sure this idea is familiar to many of you. The idea of collaborative recommendation is we believe that users' tastes kind of cluster together, so users that like similar items often like other items in common. And so the standard algorithm, there are many that work this way, we sort of find neighborhoods of users with similar tastes, and if they liked it, then you're probably going to like it, and this is the kind of system that we build. But of course, that can enhance these kinds of biases. So if a subgroup there of peers is biased, then the recommendations they give will be biased, and the loop repeats. So our idea, and I really can't say this is totally original, we stole it wholehearted from Learning Fair Representations, but the idea is let's try and make sure that the neighborhoods by which we generate recommendations are somehow more blind to the sensitive feature that we care about. So if some regions are less likely to be funded than others, let's make our neighborhoods for those items be inclusive. So here we see an example. We have let's say shape is our protected feature, and the square users in this case are in the minority. And if we create a neighborhood that just has the square users, they're going to be in this sort of self-reinforcing group. You could imagine, for example, women only seeing jobs that have been recommended to other women and not jobs that have been recommended to men. So a balanced neighborhood is one that actually contains some kind of equality across the different protected and unprotected groups. So that's the bottom part of the figure. Here, the green square has both square and circular neighbors, and so this is the idea. All right, so our solution, I was told not to put any equations on my slide, but other people did, so here it is. So we used a variant of this nearest neighbor technique called SLIM. It learns the weights for neighbors, and we set up the optimization so it prefers neighborhoods that are balanced between the protected and the unprotected group. So a couple things to note about this. It's not intersectional, so we're just looking at one division. We'll be pretty soon working on that other part. It's not class blind, so we're actually taking into account who's in the protected group and who's not. And we're not directly optimizing for equity, so we're not saying we want to achieve this balance. But interestingly, it occurs. Okay, so, and I don't have any figures here, those are in the paper, but in both provider side and consumer side case, we were able to get more equal recommendation rate across the different groups. So for example, in provider side fairness, we were able to equalize the number of loans from protected and unprotected regions across the recommendations that we were giving. And similarly, in the consumer side, that was a movie example. We could see that protected and unprotected users were getting more, their recommendation lists were more similar to each other. And I think this is very interesting, minimal loss in accuracy, and actually in the case of Kiva.org, with this data set, we actually got better accuracy. Okay, so we could have our cake and eat it too, which is nice. Okay, we're still doing a lot of work with this model. And so just to conclude, I think personalization is good stuff. We had some great cupcakes last night, so I put that here. But it's not necessarily the case that that's the only thing you want in your diet, right? So you want to have personalization, but maybe you don't want to have like only personalization, right? So you don't only eat cupcakes, no matter how good they are. You can have too much, so we want to control these kinds of filter bubble effects. And one way to do it is with balanced neighborhoods, producing recommendations from diverse neighborhoods. And I'm out of time, so I'm going to stop right there.
Thanks. I was just curious if you say you need to know the sensitive feature. Actually, maybe you can just estimate it. You can just have the neighborhood be large and without knowing it for everyone, make that. So I'm just wondering if you tested that idea.
So, I mean, there's a lot of work in recommender systems on kind of neighborhood size and so forth. And in this particular variant, you're kind of optimizing the weights of the different users. So in order to really understand whether it's balanced or not, in order to optimize for balance, you actually have to know what that is. You could conceivably try and derive it in other ways or randomize in certain ways. We haven't tried that.
Thanks.
So I'm trying to think about this as you know, the consumer side and the producer side. And the consumer side has basically usually a total ordering over all the items on the other side. And in your case, it doesn't seem like that's the perspective you're taking on the producer side, or am I misunderstanding? It seems like you just want any representation, any user really matters.
So, okay, so that is that's a sort of asymmetry. That's correct. So we're basically saying, you know, what we would like to have is, you know, lists that contain items, you know, from both groups, and as long as they're balanced, it's fine. There's actually a problem with that, which is that I could then just recommend the same items from the protected group to everybody. My metric looks great, but it's not really, you know, fair in an individual fairness sense. And so I think another interesting avenue that we have yet to explore is whether we can try and look at individual fairness and, you know, how well does this work? And we haven't done enough experiments to know if that's the case or not.
Any other questions? All right, let's thank all the speakers.
Thank you.
There really isn't very much more to say, except to say thank you to all of you folks. This has been a pretty amazing experience for me. I hope everyone had an equally great time. Of course, as I mentioned, we'll do this again next year, and there'll be news about that, hopefully soon. I think we have to clear out, but I hope that people take advantage of the fact that there are many, many bars nearby, and we should continue the conversation. And so please, you know, thanks everyone, and hopefully we can continue to do this in the future. All right, bye.